69. Okay, here we go. All right, the fundamental principle of counting. Get that off my ear. All right, let's go that route. All right, whatever. Okay, so pretty simplistic. What does it involve? When there are p ways for a first choice, and they chose the letters, I did not. It's just a letter, folks. Control your immaturity. And q ways for a second choice. Whatever. Whatever. All right, here's the simplicity. These are really easy. This is just simply P times Q ways of doing both. Really, really simple. It's just multiplication. So here's a simplistic example. How many different ways can Bob wear his 2 pants and 3 shirts and 2 pairs of shoes? By the way, notice I didn't use the word outfit because guys don't wear outfits. Guys wear clothes, all right? We wear shirts, pants, shoes, belts. We don't have outfits, all right? Don't tell us we have outfits. Don't tell me you like my outfit. I don't have outfits, all right? I have clothes. All right, so doing this would be real simplistic. You got 2 pairs of pants. You got 3 shirts. And you got 2 different pairs of shoes. So how many different ways could you wear these items? Well, the answer is 12. So if you were a girl, you'd have 12 different outfits. If you're a guy, you have 12 different ways you can wear your items. All right? It's that simple. Fundamental principle of counting. Very, very easy. It's just multiplication. Here's another example. Jed has 3 ways to get to Bill's house and 4 ways to get to 6 girls. He's got 3 ways to get to Bill's house and 4 ways to get to 6 girls. How many different ways can Jed pick up Bill and get a burger? So it's real simple. 3 ways to Bill's and 4 ways to 6 girls. And you all figured out what 6 girls is? Yeah, there you go. That's because it takes 6 girls to do what 5 guys can. Yes. Probably. I should have done 3 girls. That would be about right. 5 guys and 3 girls. That sounds about right. All right, so there's 12 different ways that could take place then. 12 different routes Jed could take to start at his house and end up at 6 girls. 12 different ways. Really, really simplistic. These are easy. It's just a straight multiplication. All right, so we have these tree diagrams to try to illustrate the possibilities. So it's used to illustrate the choices. So here's what we're going to illustrate with the first example. Jill has 2 skirts, skirt 1 and skirt 2. Sounds like cat and hat to me. All right, and they coordinate well with her 3 blouses, blouse 1, blouse 2, and blouse 3. All right. So I already started the tree diagram for you. It starts at a point, and because there are 2 first choices, I have 2 lines coming from this point, right? So I started at that point because there are 2 choices. The one was skirt 1 and the other was skirt 2. Now from each skirt, we have these 3 choices, right? Blouse 1, blouse 2, and blouse 3. And so it's exactly what will go there. And not only do you have those three choices from skirt 1, you have those three choices from skirt 2. Please take note how the skirts line up in a vertical column. Please take note how the blouses line up in a vertical column. By the way, how many total choices? 6, right? And girls, you can say outfits, right? 6 outfits with your 2 skirts that coordinate with your 3 blouses. What's the moral of the story? By coordinating clothes, you get more outfits. Yeah. Any questions on that so far? Pretty simplistic stuff. Again, though, pay attention to detail. Things are lined up nicely, right? Line them up. So on the back, let's do one more tree diagram, or the next page, let's do one more tree diagram here. And so again, notice that the tree diagram starts at a point, and I did this for you already. So in the book for homework, you're going to have to do it from scratch, and that's how you want to start it. Now, why do I have 3 branches? Because it says the first place has numbers 1 through 3. So, I got to look at this and say, well, how do I want to represent the 1 through 3? And my estimation, I just went with F for first, and the first could be a 1, and the first could be a 2, and the first could be a 3. Does that make sense? Look, you could put Q1, Q2, Q3 if that floats your boat. You could put C1, C2, and C3. There's no right way or wrong way to call the first item. I'm just thinking the first place, so I put F's. The second place, I'm going to use S's. Jack? No. The first 3 digit. The first. All right, so here's what we got. Show the choices of a lock. It has 3 places where the first place is 1 through 3. Okay? So there's the possibilities. You could have a 1 in the first place, or a 2 in the first place, or a 3 in the first place. That makes sense? Okay. So now we got to go to, I'm going to use my blue next. Now we got to go to second place, and that's A or B. So again, I've got to now, off of my first, I'm going to make this, give myself enough room. And now I got to go second A or second B. And I'm going to try to make the next one line up. Second A or second B when you do a 2. And then again, a second A or a second B when you do the 3, right? Hopefully that's high enough, guys. Sorry. We got to start wide enough, Jordan. Because we're not done. We still have one more we got to squeeze in and line up. I'm going to do the last one in green. The third place has red, green, blue. So look, starting here, I got to go a spot for red, a spot, oops, that isn't good there, a spot for green, and a spot for blue, right? So third red, third green, third blue. And again, I got to have room up, straight, and down for third red, third green, third blue. Now, Jordan, do you see why I needed all that space? Third red, third green, third blue, third red, third green, third blue, third red, third green, third blue, and I'm not even done yet. Third red, third green, third blue. And I tried to line things up. Count the green choices and you'll know how many possible. 3, 6, 9, 12, 15, 18 ways. So this is kind of a combination lock with only a 1 through 3. only an A and a B and only a red, green, blue would only have 18 different combinations. That would be it. Which, by the way, if we follow the fundamental theorem of counting, 3 times 2, right, A and B, times 3, notice 2 times 3 is 6, and 6 times 3 is 18, and of course, you would get the same amount the 18 different ways. Fundamental theorem of counting. Don't pack up. Do not pack up, please, Jack. You'll have to do some trees tonight, yes. So again, please note the aspects of a tree. Notice they start from a point with nothing there. You'll use as many lines as there are first choices. We had 3 choices, so we had 3 lines. Next, again, how many choices? Third, how many choices? And you keep your tree going. Line things up. Lined up. Lined up. Lined up. All right, all you sloppy people, you got to get rid of the slop. Right. Any questions? Any other questions? Alexis. You can use graph paper because that will allow you to keep things lined up. You don't have to use graph paper, but you can if you want to. The biggest trick is knowing how big to make the thing. So if it's got a lot of choices, you got to have it big enough because everything's got to fit in between. So you got to kind of get an idea before you start off. Any other questions? All right, here's your work for tonight. This is page 422. Let's do 2, 4, 9, 11, 12, 15, 18, 19. We'll finish off with 22 and 28. Some of them do not involve the tree diagrams. They'll go pretty quickly. Remember, though, you do need to write the original. Let me say one more thing about that. Listen now for a minute. Look, again, please understand. I don't want somebody who's obedient to get frustrated that they're complying with what I ask and writing out the whole original, and then someone who doesn't gets the same grade. That would frustrate those who are trying to be obedient, and I in no way want to frustrate those who are trying to be obedient. So stop losing points for being foolish and not writing the originals, okay? All right, that's it.